Today we are going to start a new chapter called IP routing. In the last chapter we covered switching, which was talking about MAC addresses, VLANs, and such kind of stuff. So in this chapter we are going to go to layer 3 of the OSI model, the network layer, and discuss how IP traffic is routed across an IP network. So of course the main network component or the main network device in this scenario is going to be a router. So let's start. So in this first lesson we are going to give you a conceptual overview of what IP routing is all about. Then in the next lessons we are going to do some labs and see some examples of how this IP routing is implemented using routing protocols. So we are going to start this example. This is like a conceptual overview of what IP routing is all about. So we have two parts. In the upper part, we have the mail routing. You know, the mail system where people using the post office to send letters to remote receiver. So here we have a sender with a name. He lives in a particular city. On the other hand, on the right side, we have another receiver, who has a name and he lives in another city. So to send a mail from the sender to the receiver, we need some kind of a mail carrier. So we assume that along the way between these two people, the sender and the receiver, we have three post offices or mail offices. So what's going to happen is that as this guy, the sender, wants to send the mail to the receiver on the other side, he can only send his envelope or his data to his local office, office 1. So office 1 is in the same city as the sender. So this sender only knows this office. He does not know this office or this office because they are located in different cities. So what he's going to do is that he's going to send his envelope or letter to his local office. So when he sends this local office, then he on the top of the envelope there is information, the destination and the sender and everything. So this office determines where to forward to this mail so that it reaches the receiver. First of all, this office 1, he doesn't know where this receiver is because they are in different cities. So what he's going to do is that he's going to forward this mail to the next carrier along the way. Then office 2 or the second carrier is going to inspect the envelope. Then he determines that okay, the best way to send this mail is to office 3 or the carrier 3. So office 3 or this mail carrier is the local office of the receiver, and then he sends the receiver comes and picks up, or he sends this to his home or location address. This is the same concept as IP routing. So on the lower portion of the diagram we have data routing. So we replace mail with data communication and ICT networking. So of course any devices, we don't have senders or letters, we have PCs or computers. So this computer wants to communicate with another computer, PC2 on the right side, or sometimes he wants to access some service on a server around here. So what he's going to do is that the IP traffic he wants to send, for example, maybe this is a financial report, maybe this is a email, maybe this is a file upload. So when he wants to send this data, he only knows his local office. So in the networking term, we call this a default gateway. He only knows his default gateway, which is the router he is connected to. So he will send the traffic toward his gateway. The gateway, then what he's going to do? He's going to inspect the IP packet, and the way he's going to do is that the router has what's called routing table, which is a database local to the router. So all networks in which this router now are stored in the routing table. We are going to see in a moment the structure of the routing table. This router then determines that, okay, in my routing table I know where to forward this IP packet. So he forwards to the next hop. We call it the next gateway or the next hop along the way. Then this router inspects and then says, okay, I know according to my routing table, I know where I can forward this IP packet to. Then he forwards to router 3. Now router 3 is the gateway of PC2, and then the IP packet arrives at PC2 or maybe at the server. So again, this is the main concept of IP routing. We have routers, then the routers they got what's called routing tables. The routing table is like it tells them how to forward IP packets, where to forward. So I think you have some now a concept of ideas. So let's say something more about this. You know, to implement this IP routing, we need something called routing protocols. So we have two main tables. First of all, routing protocols, their function is to forward IP traffic from one router to the next neighboring router. And by doing so, they use what's called the best path between the source and the destinations. So this means between the source and the destination is where we got many different paths, and it is the job of the routing protocols to tell the router which path is the best. So best, when we say, maybe it comes in two ways. Maybe it is the shortest path so that we don't get involved with a lot of delay, or it is the fastest link. So there are two routing protocols, and one of them is called link state. They just determine the best path using the best link in terms of speed and bandwidth. Okay, there is also called another one called distance factor routing protocols, which determine the best path using the number of routers along the way. So in this means they choose the shortest path as the best path. We are not going to cover distance factor in this course because one example is a RIB, routing information protocol, even though it is required for you to learn when you are doing networking, but it's not used in practical sense, so we are not going to cover it and waste the time on it. So in that sense, we have two types of routing protocols. We have static routing and dynamic routing. So static routing is a routing protocol in which the ICT engineer is going to manually configure. With what this means is that you always have the best path configured by the ICT engineer, whereas in dynamic routing protocol is routers dynamically choose the best path, use dynamically. So the role of the ICT engineer in the dynamic routing protocol is only to enable the routing protocol and add the networks, the destination networks. But it is the job of the dynamic routing protocol to determine the best path. So to understand more the best path, let me show you a practical example using the Google Map. So in the Google Map, normally when you are driving a car, you use a GPS and a map to tell you where the direction you are going. So if I go to Google Map, for example, and what I can do is that I want to show you a clear conceptual example of what I mean. Best path routing protocols, they determine the best path towards a destination network. So let me choose, I'm living right now here in Mogadishu, so let me go to Mogadishu. So you know, Mogadishu is the capital city of Somalia. I think most of you have never visited because of security issues. So what I'm going is that along here, somewhere around here, there is a well-known junction called Kilometer 4. It is the hub of the city. So I want to drive from this Kilometer 4 all the way to, this is Turkish hospital in around here. So which way can I take? Okay, from here I can take this path, this road, and then I can turn left, then I can come to the hospital. That's one way. I can also take this lefty sided route, and then as I go, then I turn up and then I go to the hospital, or I can go along these small alleys and then I can go to the hospital. So you can see from where I'm going to where I'm going, I can have many different paths. The question is which path is the best. So when I'm driving a car, I'm considering which path has less jam, traffic jam, which way is the shortest so that I don't use more fuel. So networks are like that. They just say, okay, which path has the fastest link? So if they see a link, for example, in link state order protocol like OSPF, they just look the different paths, and if one link is a fast Ethernet, which is 100 MB, and another link is 1000 MB, which one is a gigabit Ethernet, they always select the gigabit because it has a larger bandwidth. The connection is going to be very, very fast. So let me use in this Google Map. Let me now ask the GPS to determine for me the best path. So I go here. I'm going to open this one, close this one. I'm going to say direction is. So I'm going from here to the hospital. Now in a moment he's going to show me the best path. You see this blue line is now the best path. Now the GPS recommends me to take this one. He says this is the best path to go to the hospital. So this is the same as routing protocols. They determine, especially the dynamic routing protocols, they determine the best path. In static routing protocols, you, the ICT administrator, is going to determine the best path. And if that path fails, you have to again set up another path manually. This is again another difference in dynamic routing protocol. If the best path fails, the traffic is rerouted to the second best path. So having said that, let me just give you an overview of what we are going to cover in this chapter. We are going to go to static routing in the next lesson. Then next we are going to go to OSPF, which is one of the most important dynamic routing protocols. Then we give you an overview of BGP, which is the main routing protocol used on the internet. This one is we are going to, because in this course we are building an enterprise network, we are not an ISP, so this one we are not going to go into deep. So the question is, as routers LAN, the different networks, different destination networks, why are they going to store that information? They are going to store database called routing table. So when you are in Cisco or maybe in different vendors, you have to use the best command to see the IP route. For Cisco case, you type show IP command on the router CLI, and then you are going to see the routing table, and then from there you are going to see which network the router knows so that it can forward traffic to. Anything that's missing there means the router has no information about it and how to reach that network. Now having said that the router is stored the information in the routing table, now let's see the structure of the routing table itself. So this is how the routing table looks like. On the left side it's going to give you some codes which stands for the how the router LAN has learned about this network. So for example, in this router we have 1, 2, 3, 4, 5. We have 5 networks. So 2 of them, it indicates C. So that means those are directly connected networks. When the router's interfaces are configured, before any routing protocol is enabled, the router always knows network is attached to its interface directly. So we call them directly connected network. It gives the CLI gives a C code. So whenever you see a C, that means this network is attached on our local interface. So we have dot 96 and dot 144. Now the L means it is the interface IP address. So when you have this network attached, this is the network that's attached on my interface, but this is my IP interface address. So they are different. This is the network. This is the IP address assigned manually on the router interface. Then on top of here you have S. S means static route. This means that this router has learned remote network by using static route. It means that to reach, this is a destination network. This is not connected to my local interfaces. So to reach this remote network, I know where I can go. So any traffic that's going to this destination network will be forwarded to this IP address. So this is the next hop we were talking about. So if we break down and take one line and down, So this is the parties that you are going to see for each entry in the routing table. So the first letter, for example, now O means OSPF. So this route I land using OSPF routing protocol, and this is the destination network I land, and this is it is the mask or subnet mask slash 30, and then I land via this interface or this next hop. So it means that because I land from this interface, then any traffic going to this destination network will be sent to this interface. These two numbers in the bracket is 110 slash 2. 110 means administrative distance. We are going to see it in a moment. And the next one too is a metric, which is a number calculated using which indicates the best path within one routing protocol. So in OSPF, if we have OSPF all our network, the metric will determine the best path, and it is really calculated using some formulas. We are not going to see. We are going to see a little bit about the administrative distance next. So administrative distance, sometimes on our network like this one below, we may have on our router, we can run different routing protocols. So the question is, for example, if I tell the router, please to reach this destination network, you have two paths. This path I allow you to use a static route, and this path I allow you to use OSPF. The router has to use only one of them. So which one is going to be the best? So that's where the concept of administrative distance comes to. It just tells when you are using different routing protocols, it tells which routing protocol is the best to take. So the lowest win is that because the administrative distance is just a number. For example, on this table we have the network is that directly connected on the router interface. You as administrative distance 0 is assigned. Static route you have 1. OSPF you have 110. So the lower the best. So if, for example, there is nothing better than network that's a cable that's directly connected on my interface. If I have that one, I will take always that one because it is directly connecting, and the destination is the other end of the connection. Static route will be the next one, and the OSPF will be the last. So it means that, for example, in this kind of network, the router is going to send the packet along the static route because it has the best administrative distance, which is the smaller one. So this is it, the main concepts of IV routing. In the next lesson, we are going to discuss how to implement static route on our network and how to test it. So see you there.